Hello, this is conservation of energy experiment using a pendulum. I'd like to explain the part that usually gets wrong and also using a picture. So we have a string. At the end of the string, we have a piece of weight. So that makes a pendulum. In the lab, I usually put this on the clamp. So then that's how to fasten it. At home, you need to be creative, I guess. You either find um, you either maybe go to your closet and find out a rack where you can tie the string. You'll find something that where you can tie the string. If there's nowhere, absolutely, you can find to tie your string, I guess we're gonna have to simulate, find somebody who can hold the string pretty steadily for you. But it's likely, if you look, you're likely gonna find somewhere where you hang your clothes. That might be where you can hang this, you can tie the string. Anyway, so you fasten the top of the string. Okay, initially you want to move, you want to raise the bottom of the pendulum. That's the weight. So here, if you look at the smaller picture, that's when the pendulum is at its natural state. That's when we do not move it. So it's at its lowest state. Whenever we move it up, and then we're going to increase potential energy and start the motion. So here is lowest state in the smaller picture. In the bigger picture, then I start to move it away from the lowest place. When I move it away from the lowest place, I need you to either use your phone or a protractor to measure the angle. When the angle is less than 15 degrees, you have the best experimental results. So I like you to control it under 15 degrees. Okay, so in terms of conservation of energy, in this case, there are two quantities involved. In this experiment, when the pendulum is swinging from the highest place to the lowest place, the first quantity is the potential energy. When you raise it higher, it has more potential energy. So the potential energy equals to the mass of the object times gravitational acceleration and times the height. Okay, speaking of height, there's one thing I really have to point out, okay? Because a height can be measured in many different ways depending on your reference system. You can reference the sea level. That's actually what we call altitude. You can reference the ground outside. You can reference to the floor. You can reference to the tabletop or the top of the lab bench here on campus. In our experiment, you have to pick a reference point, and a convenient way is to pick the tabletop as the reference point. So I put my ruler to measure from the tabletop to where the center of this cylinder is. You may use a ruler and to measure, this is how high it is. And so when you let this pendulum start to swing by itself, and then it'll swing to the natural lowest point. And when it swings to the natural lowest point, um, at that point, you will need to measure the height again. And again, you're going to measure where the center of the object is and also relative to the tabletop. So you have two different heights. You are going to use these two different heights as two potential energy to calculate the potential energy. Okay, so now you have heights. Another part of the potential energy is the mass. Can you figure out how to measure the mass of this piece of weight at the end of the string? Yes, you can measure that using either your spring scale or your electronic platform scale. Either way can let you measure the mass in grams or measure the convert that grams to weight. So that way you know the potential energy of this swing object on both locations, that high place and the low place. Okay, at the high place is when you start the motion from rest. Rest means zero kinetic energy. And the bottom is when the difference in the potential energy is turned into kinetic energy. So this is how this experiment is set up and the measurements are done. I want to summarize that we learn to measure the height of a cylinder at the end of the strain. And using that height and combined with the mass of the cylinder that we can also measure. So we measure height, we measure mass, we can calculate the potential energy of the cylinder at two different locations. So that's the measurement we perform in the conservation of energy pendulum experiment. So from this information, you'll be able to calculate the speed of the weight at the bottom of its pendulum swing at the lowest position. That is the setup and measurement using ruler, using either cell phone or protractor, and using a scale to measure the mass. That's the three measurements we make in this experiment, and you will be ready to analyze the experiment.